The telescope has captured something extraordinary at the edge of our cosmic neighborhood. The James telescope has zeroed in on Proxima B, the closest potentially habitable exoplanet to Earth. We recall that a possible city created by intelligent life had been detected, which to date we do not know. The recent James Webb discovery shows how the brightness of the artificial lights of the city of Proxima B has increased. In addition, the chemical composition of the atmosphere of this exoplanet has been discovered. So join us on this incredible journey to Proxima B to discover the details of this discovery. According to NASA's director, the JWST may have used all this technology effectively and has detected life on Proxima B, an exoplanet located just 4.24 light-years from our solar planet. Proxima B has become a phenomenon of fame due to its potential to be habitable. This exoplanet orbits its parent star, Proxima Centauri, a red dwarf that is much smaller and cooler than our Sun. Discovered in 2016, Proxima B lies in the star's habitable zone, also known as the Goldilocks zone, which is the region around the star where conditions could allow the presence of liquid water, a crucial ingredient for life as we know it. Proxima B's proximity to Earth and its location within the habitable zone have generated enormous interest and speculation about its ability to support life. However, it is important to keep in mind that the habitability of an exoplanet is a complex puzzle involving numerous factors. Proxima B is classified as an exoplanet with a mass approximately 1.3 times that of Earth and has an orbital period of approximately 11.2 Earth days, meaning that it completes one orbit around Proxima Centauri in that time. However, things are not as simple as we may think. The fact that the planet is Earth-like in size and orbits a red dwarf does not guarantee that it is an exact replica of our world and that we can all move there. The habitability of Proxima B is determined by multiple factors. One of them is the planet's atmosphere, which acts as a protective shield and plays a crucial role in regulating temperature and life in general. However, the exact composition of Proxima B's atmosphere is still unknown, making it difficult to definitively determine its habitability. Scientists are working on methods to study the atmosphere of Proxima B, and a key tool in this process is the James Webb Space Telescope. This telescope will allow scientists to analyze the light that passes through the exoplanet's atmosphere during transits, which will give them information about spectral characteristics and help them search for possible biomarker molecules that could indicate the presence of life. Another important factor affecting habitability is the presence of water. Although Proxima B is within the habitable zone, it is crucial to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a critical piece of the puzzle, and scientists are looking for signs of liquid water on the planet's surface, whether in the form of oceans, lakes, or rivers. These clues could be key to assessing the possibility of habitability on Proxima B. The presence of water in other states, such as ice or vapor, is also considered because water availability is essential to support biological processes and is considered a key indicator of habitability. The presence of Proxima B raises questions about its climate. Scientists must also investigate factors such as temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a suitable range for life to thrive. Extreme conditions such as scorching heat or extreme cold can make survival difficult. Stability is also crucial. Volcanic eruptions or seismic activity can disrupt habitability, but stability is a good sign. Proxima B is believed to be in a tidally locked state, meaning that one side of the planet remains permanently in darkness, while the other side is permanently illuminated by the star. The stark contrast between the illuminated and dark sides could generate temperature variations and dynamics that could affect the planet's habitability. These are just some aspects that scientists are considering in the search for habitable planets. Scientists are investigating the chemical composition of Proxima B to analyze the presence of organic compounds, such as amino acids and other molecules essential for life. They are also examining whether the planet receives enough energy from the star or other sources to fuel biological processes and allow organisms to grow, reproduce, and thrive. However, despite all these studies, the question arises as to whether Proxima B actually possesses all the necessary elements to be considered a habitable planet. Is there concrete evidence for this? Well, the discovery of Proxima B in 2016 was a remarkable achievement. Astronomers used a high-precision instrument called the High Accuracy Radial Velocity Planet Searcher, HARPS, to detect the subtle gravitational tug of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph is designed specifically to detect exoplanets and operates at the La Silla Observatory in Chile. It has been crucial in the discovery of numerous exoplanets, including Proxima B. The HARPS instrument operates using the radial velocity method, also known as the Doppler spectroscopy technique. Its function is to detect exoplanets by measuring the subtle shifts in the star spectrum caused by the gravitational pull of an orbiting planet. These shifts, known as radial velocity or Doppler effect, occur due to the slight wobble of the star as it is dragged by the gravitational interaction with its companion planet. HARPS has an optical fiber that collects the light from the target star and directs it to the internal spectrograph. Inside the spectrograph, the light is dispersed into its different wavelengths, allowing astronomers to study the star's spectrum in detail. In this way, scientists can determine the star's radial velocity with exceptional accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses technologies and techniques that include a temperature-controlled environment. This allows stabilizing the instrument and minimizing the effects of thermal variations that could interfere with accurate measurements. Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics, such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These superhabitable planets, as Michio Kaku calls them, are fascinating and possess exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these superhabitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, as he predicted, in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in place in case something catastrophic happens on Earth, such as a meteor impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first step to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets, or even better planets called superhabitable planets, that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by René Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as the only known planet with life, meets the necessary criteria. One of the main criteria is the presence of liquid water. It is for this reason that we search for a planet similar to Earth in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal to or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a moon with a richer range of flora and fauna compared to our own planet. Such a world would show a higher degree of environmental conduciveness to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey, as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of superhabitable worlds. Among the promising targets, Alpha Centauri B has emerged. Alpha Centauri B is part of the closest star system to our planet, which makes its potential exciting. However, so far no planets have been confirmed to be present in this system, much less superhabitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri B. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets but also possibly superhabitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri B has been identified as residing in the star's habitable zone, which is an exciting discovery. However, there is also a potential downside. Since Proxima Centauri is an active star, it could emit significant flares that could negatively affect the habitability of the planet. Although Proxima B is the closest known habitable planet, it is worth noting that there may be other stars and exoplanets that offer even greater promise in terms of habitability. For example, Tau Ceti is the closest single star system to the Sun that resembles our solar system and is only 12 light-years away. It is of particular interest to scientists because it is considered superhabitable. According to Michio Kaku, Tau Ceti has been extensively studied, with evidence of 5 planets orbiting the star, of which 4 are classified as super-Earths, or in other words, terrestrial planets more massive than Earth. Although none of the planets orbit in the habitable zone, they remain candidates for possible habitability. Another point that scientists highlight is that Tau Ceti is an ancient star that is more mature than our Sun. This suggests that planets in this system have had more time to form and develop the necessary conditions to support life. This is why Tau Ceti represents a fascinating candidate in the search for superhabitable worlds. Continuing our search for habitable worlds, we turn our attention to Teegarden star, an ancient red dwarf located about 12 light-years away. Teegarden star has an intriguing distinction. It hosts 2 known exoplanets, both of which reside in the habitable zone. This makes them particularly exciting candidates to consider as potential superhabitable worlds. The relatively short distance between these exoplanets and Earth provides an exciting opportunity for further exploration and detailed study. Scientists believe that these worlds may possess the necessary conditions for habitability, making them targets of interest in the search for extraterrestrial life. Within this promising context, we also come across the Kepler 442 system. Kepler 442, located about 1,200 light-years from Earth, hosts a remarkable super-Earth called Kepler 442b. This exoplanet stands out due to its larger size and presence within the star's habitable zone. Kepler 442b's unique combination of characteristics suggests that it could possess a higher degree of habitability than our own planet. These findings highlight that the search for superhabitable planets extends beyond Earth-like worlds. Planets that offer even greater potential for life may exist elsewhere in the cosmos. According to the findings of Renee Heller and John Armstrong, superhabitable planets do not necessarily resemble Earth in all respects. In fact, there are several characteristics that make these planets potential candidates for being superhabitable. Some of the key characteristics are that they have a larger surface area, with a size approximately 10% larger than Earth, and also have a greater degree of gravity. Superhabitable planets can host higher biodiversity, thanks to the diversity of microclimates and ecological niches they offer. These planets may have more stable and conducive environmental conditions for the growth and proliferation of a wide variety of life forms. They may also exhibit richer and more complex biospheres than we find on Earth. Among the potential characteristics of a superhabitable planet, the duration of its existence is critical. A planet that has had more time to support the development and evolution of life has a greater likelihood of being superhabitable. Planets that have existed for longer periods of time are more likely to possess diverse and stable ecosystems. The type of star around which these planets orbit also influences their potential to be superhabitable. While red dwarfs are common and long-lived, they can emit powerful flares that negatively affect the habitability of their planets. Therefore, K-type orange dwarfs, which offer a more stable environment over long periods, are considered more suitable candidates to host superhabitable planets. The presence of abundant water is another critical factor in the habitability of a superhabitable planet. Larger amounts of water compared to Earth may provide more favorable conditions for the development of diverse life forms. Water, as a vital element, plays an essential role in supporting biological processes. These characteristics, combined with more temperate climates and greater geological stability, are essential to determining the habitability of an exoplanet. The concept of superhabitable planets challenges the assumption that Earth represents the pinnacle of planetary habitability and broadens the search for planets that may offer even greater potential for life. It is important to remember that our current knowledge is limited and new discoveries could redefine our understanding of what makes a planet superhabitable. Therefore, the search for superhabitable planets requires further exploration and analysis. This leads us to ask whether Proxima B could be a superhabitable planet. The habitability of an exoplanet is a complex issue, and it is not guaranteed that all of its parameters are suitable for life. Although there is evidence of a city with artificial lights and a suitable atmosphere on Proxima B, many other factors need to be studied. The ability of a planet to sustain life depends on a variety of factors that include its atmosphere, water, temperature, geological activity, and more. Additionally, as we have seen, there are many other candidates for superhabitable planets that we have not yet discovered. The search for life and habitability in the universe is ongoing and constantly evolving. The James Webb Space Telescope represents a significant advancement in our ability to study exoplanets and their potential for habitability. The search for habitable planets and superhabitable worlds continues to be one of the most exciting frontiers in modern astronomy, and new discoveries could provide valuable insights into our place in the cosmos.